exercise, we use the dichotomous search algorithm to determine the minimum of this function e to the x over 5 sine x over 5 for x over the interval from -10 to 3. And eventually we'll determine the minimiser to an error of no more than 0.05. That is, the final length must be less than 0.1. So up here is the graph of this function, which we normally won't have. And the minimum we're trying to find is around about -4. So let's see how the algorithm arrives at that. Okay, so using MATLAB or Octave, here Octave, let's do it. First thing, define the function, and for such a simple one-line function we use the @x to define it, and it's x over 5 times sine x over 5. And again we use the dot times operator so that we can give a vector of values x and get in return a vector of the corresponding function values. Okay, so we're going to minimize over x from -10 to +3, and one of the alternative ways of doing that is to use the linspace command. So let's get a vector of x values using linspace from -10 to 3. We want 3 interior points. The 2 endpoints means we want 5 points, 5 x values. At each of those x values, we want the function. We get that by saying f of x. So here it is. Here's our x values over the range. And here are the corresponding function values. And the algorithm now is, which is the minimum of these? And the answer is it's that middle value, -0.319. Hence, the minimiser must lie in the surrounding 2 subintervals. So the minimiser has to be between -6.75 and -0.25. So that's our next search interval. So, to do the next iteration of the algorithm, we go linspace from -6.75 to -0.25, and we want 3 interior points and the 2 endpoints, so we want 5 x values spread across that interval, and we also want the function values at each of those x. So these are now the new x values. Here are the corresponding function values. Where is the minimum? Okay, and the smallest f in these 5 is -0.319 again. So that tells us the minimiser is in the surrounding 2 subintervals, so it has to be somewhere in that interval. Right, so the next iteration of the algorithm is x is linspace from -5.125 to -1.875, 5 points, and we want f evaluated at each of those. So here are the x values in this iteration, and here are the corresponding function values. And where is the minimum? The minimum lies there. So again, the minimiser is in the surrounding 2 intervals, subintervals. So the minimiser has to be in that interval of x. Right. And the algorithm continues on like that. This is all I'll do because you can get the picture. But the best way to do this repetitively is via a coded MATLAB Octave function. And that's what we'll do next.